Students, we're talking about the forward error correction, and the technique that we are going to be talking about, the FAC technique that we are going to be talking about in this discussion is chunk interleaving. Students, chunk interleaving, it works with a basic concept that not all the chunks in a packet it can be lost. If all the chunks in a packet are lost, we are essentially losing out on the whole packet, and therefore we cannot recover the information in a meaningful way at the receiver. But we can have some of the chunks in every packet that we can afford to lose out on. Students, even if you have got some chunks missing in a packet, we can still reconstruct the data using whatever we have left or most of the chunks that we have left with in the packet. On the slide, what you can see is we have got some packets on the left hand side. Precisely, we have got 5, and we have divided each packet into 5 chunks. Normally the number is much larger, but for the sake of the discussion in this particular case, we are dividing each packet into 5 chunks. Students, we can recreate this data chunk on the receiving side, and the strategy that we are going to be using is on the receiver side, we recreate this chunk by chunk horizontally, but we can combine these chunks into the packets vertically. As you can see, on the sending end, we are sending all of this horizontally. So this is our first packet, and we are sending it horizontally. This is our second packet, and we are sending it horizontally. So I've started from packet number 5, but initially you start from this one. This is the sending column by column. This is your packet number 1, your packet number 2, your packet number 3, and so on. On the receiving end, guys, once this is received, let's suppose that one of our packets is lost. Now, although we have lost the full packet, when you arrange this back in the receiver side column by column, and you arrange this in the vertical format, your packet 1 will go back like this. Packet 2 will go back like this. Packet 3 is lost. Packet 4 will go back on the receiving side like this. And then packet 5 will go back like this. So essentially, you are not missing a full packet. You are only missing a chunk out of every one of those 5 packets. And it's easy to reconstruct this data at the receiving end using chunk interleaving. Students, we'll move on to our next technique, and that technique is the combination of Hamming distance and interleaving. Students, using the Hamming distance, we can first create an n-bit packet that can correct t-bit errors, Hamming distance. And then using interleaving, we can actually interleave m rows and send the bits column by column. And students, using these both techniques that you have already gone through, we have the capability of correcting m multiplied by t bits of a burst error efficiently. Students, last technique of forward error correction, and this technique is the compounding high and low resolution packets. Students, what we do in this technique is we actually create a low resolution redundancy version of every packet, and we embed that low resolution version in the next packet. For example, for packet 1, the high resolution version will go in packet 1, and then the low resolution version of packet 1 will go in packet 2. Similarly, the low resolution version of packet 2 will go in packet 3, and so on. On this slide, what you can see is we have got the creation of packet process is shown first. In this case, we have got a packet 1 high, and this goes into the first packet. Students, a low resolution version of the same packet will go in packet number 2. Students, packet number 2 high will go in the same packet 2, and then a low resolution version will go in packet number 3, and so on. So students, in this case, what you can see is if we have got on the receiving end, if our packet number 2 is lost, we still have a low resolution version of this packet sitting in packet number 3, and we can get that packet and we can use that to recover or recreate packet number 2 at the runtime. Students, in this method, if the last packet is lost, if this last packet is lost, then because we don't have a packet number 6, we have no way that this packet number 5 can be recovered. But using this low resolution version of the packet, and given that if it's not the last one, we can recover all the other packets that make up our transmission.